Alright guys, welcome back to the exploration of vectors. Today we will be looking at how to find the angle in between two vectors and at something called the dot or scalar product. So we have two vectors here, vector A, vector B. In between them is some angle. Oftentimes we're interested in that angle. The way we calculate that, if we have two vectors, vector A, vector B, they can either be two-dimensional or three-dimensional, doesn't matter. The cosine of the angle will be A1B1 plus A2B2, and if we have A3B3, we add that on also. Remember to leave off R2D2, but we divide that by the magnitude of A times the magnitude of B. Using this formula, we can find the angle. Now, this thing up on top, that right there, that's what we call the dot product, or scalar product. And the notation for that is A dot B. And it's equal to multiplying the x components, multiplying the y components, multiplying the z components, and then adding them together. So here we have 3 points, A, B, C. Find the size of the acute angle BAC in degrees. So let's draw this. A is the vertex, B is up here, and then we have C. We can think of these as vectors, AB and AC. If we can use that formula, we can evaluate the angle. So here we go. First we need AB. To find vector AB, we take the terminal point minus the emanating point. So we're going to do 4 minus 3, and then 1 minus negative 5, and then 1 minus 2. So vector AB is given by the column vector 1, 6, negative 1. And then we need vector AC. Pause the video right now, and why don't you try to find AC yourself? Okay, so here we go. Terminal point minus emanating point, negative 1 minus 3, 1 minus negative 5, and 2 minus 2. So vector AC is given by the column vector negative 4, 6, 0. So how do we find the angle? Cosine theta equals A dot B. So AB dot AC. So it's going to be 1 times negative 4 plus 6 times 6 plus negative 1 times 0. That's our numerator, divided by the magnitude of each vector. Magnitude of vector AB will be 1 squared plus 6 squared plus negative 1 squared times the magnitude of vector AC. Negative 4 squared plus 6 squared plus 0 squared. So what do we get here? So evaluating this, we get that cosine theta is equal to 32 over the square root of 38 times the square root of 32. So cosine theta is equal to approximately 0.7199, and that means that the theta will be the inverse cosine, and of course we're using our calculator to do this, 0.7199, and to 3 significant figures, our angle theta is approximately 44.0 degrees. Now, two vectors A and B are perpendicular if A dot B equals 0. And let's look at why this is, guys. So A dot B divided by the magnitude of A times the magnitude of B is equal to the cosine of theta. So A dot B equals magnitude of A times magnitude of B times cosine theta. Well, if theta is 90 degrees, what's the cosine of 90? The cosine of 90 is 0, so we have something times 0, so A dot B must be 0 if they're perpendicular. We're going to use that in the next example. Alright, so we have vector P, we have vector Q. Find the value of the scalar t such that vector P plus t times Q is perpendicular to 3, 5, 1. Okay, well, what do we need to do? I hope you're thinking, well, we need to write down a new vector for P plus t times Q. So pause the video real quick and write down a column vector for this. 4 plus 2t is the x component. Negative 1 plus 1t is the y component. And 2 plus t is the z component. And what we know, since this is going to be perpendicular to this vector, that means their dot product is going to be 0. So 4 plus 2t, negative 1 plus t, and 2 plus t, dotted with 3, 5, 1, must be 0. Okay, cool. Well, what do we do with that? So now we're going to do the dot product. We're going to expand this product, this multiplication. So we're going to do 3 times 4 plus 2t plus 5 times negative 1 plus t, multiplying the x, y, and z components, plus 1 times 2 plus t equals 0. And now we're going to expand and combine like terms. Why don't you go ahead and see if you can finish this. What you should end up with is 9 plus 12t equals 0. And solving for t, you should get that t is equal to negative 3/4. And ladies and gentlemen, we are done. So, to summarize, we have a formula for dot product. We actually have 2 of them. And I'll show them both to you on the next slide. So our 2 formulas for dot product, A dot B. If vector A is xy is A1, B, A1, A2, A3, and vector B is B1, B2, B3, the dot product will be A1, B1 plus A2, B2 plus A3, B3. Or we can also say that A dot B is equal to the magnitude of A times the magnitude of B times the cosine of theta. And that theta is the angle formed by those 2 vectors when they're emanating from the same point. And there you have it, ladies and gentlemen. We are done for today.